The journey to calculus 3. We continue from the previous lecture. We will go over kind of problems from pre-calc to recall important information we need for the calculus class. One thing I'm going to go over to recall is the sigma notation. This is the summation notation or sigma notation of, let's say, EI, where I changes from 1 to n. And what does that mean? You're summing up over all the I values. So you place I with 1, I with 2, I with 3, and it can go all the way up to n. The sum of natural log of xi, as another example, I goes from 1 to t. Same thing, it's natural log of x sub 1 plus natural log of x sub 2, and this goes on and on until natural log of x sub t. This is called the sigma notation. Now we can go backwards, maybe right, using sigma notation. So they will give us the sum and they require us to find or write this using sigma notation. So how do you do this? Well, there's many ways to write this out. I see ln in all of them, and I see x in all of them, plus. The number that's changing is 1, 2, 3, all the way up to k. So you can call that I, and say I goes from 1 to k. So this is called sigma notation. You can calculate if there's like a value you want to find the exact value for. You can actually put that on the calculator and find the value. But not this one, but could be something else. Let's say they ask you to evaluate something slightly different. The sum of just n goes from 1 to 4. Make it that simple. So you can substitute n1, n2, n3, n4 and add them up. And that can be used, also can be done on the calculator. Another thing we need to talk about is the domain. How do you find domain for a given function? Let's look at some examples. Say the natural log of 4 minus x squared. How do you find the domain for such a function? Well, the way we do it, anything after the ln has to be bigger than 0. So 2 minus x, 2 plus x has to be bigger than 0. And to solve inequalities like this, we should use the number line. So we have a 2, negative 2, like that. We take x equals 3, that's a negative. If you take x equals 0, let's say, that's going to give 2 times 2 positive, and then negative. So negative, positive, negative. The question is asking, when is it negative, positive? Well, that's when it's between negative 2 to 2. That's the domain. That's the domain. That's the interval notation. Another example, a function we need to find the domain for, something like this. So how do you find the domain of this function? First thing, for the denominator, this thing is always never equals 0. This will never be 0 because that's a positive quantity. But also under the radical sign, this should be bigger than or equal to 0. So x bigger than or equal to 1. So domain is 1 to infinity. Domain is 1 to infinity. Next one, 3 times the absolute value of 2 plus x minus 5. So how do we do this? This is an absolute value function. All absolute value functions and all polynomial functions, they have a domain is real, all real numbers, negative infinity to infinity. All real numbers. We can look at a more difficult one, say the square root of 4 minus the square root of 4 minus x squared. So what we do here is the quantity under the first radical, the big radical, must be bigger than or equal to 0. And also, the quantity under the smaller square root must also be bigger than or equal to 0. For this one, we can add this to both sides, squaring both sides. Then subtract 4 on both sides. This is negative x squared. Subtract 12 on both sides. Then multiply by negative. This can be rewritten like so. This is bigger than or equal to 0 for all x. So for this part, it's nothing. It's going to change because this quantity is going to be always bigger than or equal to 0, no matter what x is. No matter what x is. For the other one, we need to factor this out. 2 minus x, 2 plus x. Then we have a negative 2 and a positive 2. If you take a 3, actually that would be negative, then positive, then negative. So that would be negative 2 to 2. So the domain for everything, actually for the first one is all real numbers. So for the first one is just the entire number line. But for the second one, it's only negative 2 to 2. So it's only from here to here. So they both overlap from negative 2 to 2. And that would be the final answer. Now we can review some graphs. Let's talk about the opposite value of x. Each one should know how this looks like without a calculator. Goes like a V shape. And this can be used to graph, let's say y equals opposite value of x minus 2, or y equals opposite value of x plus 3. So to graph the first one, we just shift the graph of this 2 units to the right side. So it goes like this. This is the graph for y equals opposite value of x minus 2. Next one, 1, 2, and 3. That's the graph for the second one. We shift the graph 3 units up. So the range here is 3 to infinity. Or you can say y bigger than or equal to 3. That's the range. Domain all real numbers to all of them. Range for this one is 0 to infinity. So that's the y values. Or y bigger than or equal to 0. How about graphing something like y equals natural log of x minus 2 and find its range. So recall that the graph of y equals natural log of x, that's the parent function, goes up this way. There's a 1 here, 0, like so. And the domain for this function is 0 to infinity, and the range is all real numbers. But what we do, we shift the graph of y equals natural log of x 2 units to the right. 2 units to the right to obtain the graph of the function we're looking for. So it means you may pick points on this, say 1, 2, 3 points. Shifted 1, 2 steps. 1, 2, that's a 3. 1, 2. So it goes up this way. That's the graph y equals natural log of x minus 2. So the range stays the same. The only difference here is the domain. So whatever we had here, this is x equals 0. From here, x equals 0 is the vertical asymptote. But now, for y equals natural log of x minus 2, if you set this part equals to 0, you will get x equals 2 is the vertical asymptote. Vertical asymptote. And so that would go something like this. There's a vertical line here. This is x equals 2. other graphs to know, let's say cosine x. Y equals cosine x. So we need to know that as well. 2 pi over 2, 3 pi over 2, and 0. So it starts here at this point 1, then it goes down to -1, 0, then 1 again. Then how do we graph y equals 2 cosine x? What the 2 does is basically it changes the amplitude. It changes the amplitude. What the amplitude means is going to become 2 instead of 1. So the graph would look like 2, and then everything on the x-axis stays the same, 0. That's going to go down to -2, 0, and then to 2. So that's the range, the graph. Now, the range for this is from exactly -2 to 2. So how do we work that out? We know that cosine x is between -1 and 1. That's another method to look at this. If you multiply everything by 2, you get 2 cosine x less than or equal to. But this quantity here, that's the y value. So -2 less than or equal to y less than or equal to. So you can see that the range is from -2 to 2. We also have exponential function, y equals e to the x. The graph of this goes up this way. Domain is all real numbers. Range 0 to infinity. This line here is y equals 0, horizontal asymptote. If I want to graph y equals e to the x plus 3, we just have to shift the graph 3 units to the left, 3 units to the left, and range stays the same. How about if they ask us to graph a piecewise function, say y equals f of x, say -x minus 2 under the condition x is less than -2, x squared if x from exactly -2 to less than 2, and square root of x if x bigger than or equal to 2. We need to find f of -1, f of 9, f of -4. We're going to find them and then graph it. So f of -1, -1 falls under this condition. So we're going to substitute that there, -1 square, which gives us 1. F of 9 falls in the third one, so square root of 9, which is 3. The last one falls under the first one, -4 minus 2. That's a 4 minus 2, which is 2. We're going to graph it now. How do we graph piecewise functions? We graph the first one. The first one is y equals -x minus 2. So -x minus 2, you can take x equals 0, y -2. X equals -1, y equals -1. So it says, this is -2. It says graph it when x less than -2. So at that point, we make a hole. So it's only to the left of x equals -2. Only to the left. And less than only, not less than or equal. That's why it's an open circle. The next one is a parabola, y equals x squared. So if you substitute the -2 in, that's going to be here. And if you substitute the 2 in, that's going to be there. So it's going to go down like that, 1, 2. The next one is y equals the square root of x. It starts from 2 on. Here it says not equal, so we put an open circle. But for this one, when x is 2, y is 1. Not 1, actually, it's a little bit above 1. This is 1, 2, so somewhere here. And we know the square root of x goes this way. So what would be the domain for this is really all real numbers. And the range is from 0 to infinity. Other things I would like to review is rationalizing the denominator. Let's say rationalize the denominator for the fraction 2h over the square root of x plus h minus the square root of x. Rationalize denominator means rewrite this expression with no radicals in the denominator. So you multiply top and bottom by the conjugate. The conjugate is you do the same thing in the denominator, just switch the middle sign. Just switch the middle sign. So that gives us, keep the top the same, 2h times all of this. Denominator, they're the same with the different signs, so that's a difference of squares, so it's like a squared minus b squared. Then keep the top the same. This is x plus h minus x. These cancel out. And that would give us 2h times the square root of x plus h plus the square root of x all over h. These cancel out. What does that give us? 2 times the square root of x plus h plus the square root of x. Or you can multiply the 2 in. So what we did, we rationalized the denominator. We rationalized the denominator. So what about if they ask us to rationalize the numerator for the expression square root of x plus h plus square root of x? Well, there's no denominator here. That means it's over 1. So I can rewrite this as square root of x plus h plus square root of x over 1. Multiply top and bottom by the square root of x plus h minus square root of x over square root of x plus h minus square root of x. And what does that give us? Keep this the same. On the top, as we did in the previous example, we take the first one, we square it, and always minus the second one, we square it. What do we get for that? Keep this the same. The top, you get x plus h minus x, so these cancel out. So h over the square root of x plus h minus square root of x. Another example, rationalize the denominator for this. How do you rationalize the denominator? We need to multiply top and bottom by the conjugate. Square root of x minus square root of y, square root of x minus square root of y. We keep the top one the same as written as a product, like so. The denominator, you take the first one, you square it, minus the second one, you square it. X minus y, square root of x minus square root of y over x minus y. These cancel out. So that gives me the square root of x minus square root of y. Another example, x over the square root of x plus 1 minus 1. How do we rationalize this? Rationalize, you can see you need to rationalize the denominator because the the radicals are only in the denominators. So we multiply by the conjugate. So x times the square root of x plus 1 over square root of x plus 1 square minus 1 square. Keep the top one the same. The bottom is x plus 1 minus 1. These cancel. And also the x cancels. So that gives us the square root of x plus 1 plus 1. So that's about rationalizing. Another thing I want to review is how can we solve equations such as 3e to the x plus 3 minus 6x e to the x equals 0 using a graphing tool. There's many ways to do this. One way is to graph. This is the function, let's call it y equals 3e to the x plus 3 minus 6x ex. And this is just y equals 0. This is the x-axis. So what we can do, we can use Desmos. And find the point or points of intersection between the two graphs. The two graphs means the graph of this first function, y equals 3e to the x plus 3 minus 6x e to the x, and the x-axis. And if you do so, I just found out that x is about 0.7388. You can click on that point on Desmos and it will give you the exact coordinates, both the x and the y. But we just need the x here because y is 0. So the next one, as a general question, let's say we are given a equals 2b squared and capital B is 3b. We need to solve for b in terms of a. So how do we solve for b in terms of a? The first thing we have, capital B is 3 small b. And we can solve for small b here by dividing by 3 and then substitute that into a. A equals 2b squared. So a equals 2 times capital B over 3 squared. What does that give us? A equals 2b squared over 9. 2b squared over 9. But I'm looking for b, so multiply both sides by 9. Divide by 2. So then b is what? B is this plus or minus the square root of 9a over 2. 9a over 2. But then we have a property that you can rewrite this as the square root of the top one over the square root of the bottom one. And what we need to do here, first the 9 comes outside as a 3. We need to rationalize the denominator as we learned earlier. So then b would give us plus or minus 3 square root of 2a all over 2. Another thing to review, how to find intercepts. Find intercepts for, say, y equals 2x over 4 minus x squared. So to find, let's say, the x-intercepts, we set y equals to 0. So when y is 0 means the 2x over 4 minus x squared is 0, which is over 1. You can do cross multiply. You get 2x is 0, therefore x is 0. So the x-intercept is 0, 0, which is also the same as the y-intercept. And you can see that by setting for the y-intercepts, set x 0. When you set x 0, you get y equals 2 times 0 over 4 minus 0 squared, which is 0. So again, we get the same point, 0, 0.